Um, all right, so we have 3 over 2u to the fourth v plus 3 over uv. All right, so what you want to do is you want the bottoms, because this is addition, and is addition hard with fractions or easy? Hard. All right, so we want the bottoms to look exactly the same, right? All right, so what'd you do? Okay, so over here we're gonna multiply. You said multiply by 2u cubed. So did you go 2u cubed and then 2u cubed? What did you do? Wait, you multiplied. Wait. Which bottom? Oh, on the left, on the left or the right? Hold on. You multiplied it. Let's see. All right. All right, what'd you do? 2u cubed and then one half v like this? How come? Why? Wait, so why the one half v? I see. All right. So what you want to do is always just kind of think about this, like if you're doing like 1/7 plus like 1/3. All right, so how do you add those two together? All right, so you got it. You when you're yeah. First of all, this sucks, right? This is annoying. Remember, it's the hard one. If we were multiplying, you could do this in 2 seconds. Like if you're multiplying, like what would you do if you're multiplying? What would this answer be? No? If you're multiplying, go, yeah. Wait, I want to turn on. That's it. All right, so we're adding a nightmare. So what you're gonna do is you have to both the bottoms have to be the same. So multiply right here. The top in this case, you're gonna multiply them by each other. So in this case, you'd multiply 7 here, and then 3 over here. Because what is 7 over 7? 1. So if I multiply 1/3 by 1, am I changing the 1/3? No. And then over here, I'm multiplying 3 over 3 times 1/7, so am I changing the 1/7? No. And then you get your common denominators. Okay, well, over here, you don't have to do all of, like, I used to, by the way, when I was learning, because I was just like, this is too much thinking. So I would go like 2u to the fourth v, like completely the other thing. And then 2u to the fourth v. And then here I would be like u, v, and then u. But then there's a lot of cleanup work you got to do if you do that, especially on this problem. So think a little bit. You can save yourself some work. So what you want to do is just, and it's, you just multiply top and bottom by what you're missing. All right, so like, we can kind of think about like, this guy kind of has it all actually, right? This guy has everything you need. He's got he's got too much. Um, so we need to have it. This one needs a 2. So multiply top and bottom by 2. Okay, by 2. All right. This one needs a. Well, what else is it missing? besides the 2. Yeah, but it already has a u to the 1. Yeah, so u cubed, let's see, u cubed, but top and bottom, because you want to create that, like, all together, this is a fraction that becomes 1. So, all right, so u cubed, and then, what, anything else? Would that make them equivalent, like on the bottom? Like, yeah, 'cause there's only one v, right? All right, so the bottoms are now the same. So now that the bottoms are the same, you can add the tops and keep one of the bottoms. Because this, even though we didn't put it together, is, that turned out really nice, by the way. It's 2u to the 4th v. Okay, so that's what we have. We just didn't like write it in the right order. But you can go ahead and add your tops. Don't forget to multiply these together, by the way. So if we add our tops, we're going to go 3 plus what? Wait, multiply these together. 6 u to the 3rd. Is that distribution? It's not. Distribution is when you have like this. All right. Since these are all together, you just multiply the number in the front. That's it. Once you have that plus in the middle, then you got to go like that, and you got to go like that. Yeah, that would be 6 plus 3u cubed. All right. So we're here. We got 3 plus 6u cubed. All right. Over what? Over 2u to the 4th v. Okay. Okay. Now what? Are we done? Actually, we're not done. How about we just go like that, like, and start wiping some u's out? What do you think? Here's, not because there's a 3, but because there's a plus. You have a plus, right? But look, think about like always like the Fight Club thing, like if you can reverse distribute. So if you can like if you have like if you can create a thing where you have like a number and then some other stuff in here and then there's a number over here with something right here, you can like wipe. So think about what 3 and 6, like, what do they have in common? Hmm? But a 2 can't go into a 3. They have a 3 in common. All right, so you got that 3. You go like that, and then you want to think about what would like to put this thing back together again. Like what would go here and what would go here. 1 plus 2u cubed. So that's 6u cubed. Yeah, huh? Over 2u to the 4th v. Oh, wow, wow, I actually achieved nothing. That's awesome. There's no, like, in my mind I was thinking you can wipe these out. This would have had to have been a 2. Look, we just like did nothing. we walked in a circle. All right. So yeah, so either answer is acceptable, but you can just leave it like this, huh? What's that? Yeah, I know what you're talking about. So you shouldn't for this type of problem, like, but what you can do is you can split your fraction. So if you have like, let's just say like 3u plus 17 over 9, you could write it as 3u over 9 plus 17 over 9. And then you could reduce. You can actually say, like, all right, this is 1, this is 3. I can actually reduce that thing. But there's really no point in doing that for this problem. So, all right, go ahead and punch that in. Okay, 1 plus 7 pq to the 5th over 3. Okay, so they want you to basically, when you simplify, they want you to combine these fractions, or these things. And so you want to write one as a fraction. How do you write one as a fraction? 1 over 1. All right. Can we just easily add these together? No, we cannot just easily add these together. What do you do? Top and bottom by 3 is actually easier than the last problem. Top and bottom by 3, and then what do you get? 3. Did you say times plus to the 5th over 3? And can you wipe stuff out? No, why can you not wipe stuff out? Yeah, I mean, the only way you'd be able to wipe stuff out is, would you say? Well, that would be like, let's say it had something like this. I mean, if I ever had something like this, then I would split my fraction. So you write it as, let's use different numbers. It's kind of annoying that they're all, well, let's make this like a 9, I guess. So you would split this one. So if I just wrote this as a fraction, what would that be? Okay. And then you use this sign right here, and then you write this fraction right here. Uh-huh. And that's how you split your fraction. Then you can reduce. Yeah. And you can reduce this one as well. Um, uh-huh. But it's trickier to do it from here. If you do it from here, you gotta say like, all right, what number goes into all 3 of them? What number goes into all 3 of them? 3. How many times does 3 go into 3? How many times does 3 go into 3? How many times does 3 go into 9? 3 times. So then it becomes 1 plus 1x, or just x, over 3. It's easier, to me it's easier to split the fraction. I like to do it like that. Okay. So this other problem right here though, this one's done. Got it? Yeah? Alright, punch it in. Okay, how do you deal with this thing? The right side, top and bottom. Alright, so you can do that. Multiply this side by 8, multiply that by 8. That's good so far. You also said multiply by x, but we don't exactly have just x on here, right? Because it has to be x to the 4th. But maybe you thought because you had a 3 here, you were good? Oh, you can't do that. That flipping only works for division. So if you have a fraction, like if you're like this, and you have I don't know, 8 over 17. How do you deal with this? You flip the right side and then you make it multiplication, right? Uh-uh. Ah. Yep. Okay. Yep, you cannot do that. So, all right, so we're here. Now what? Because what kind of we have an 8 right there, right? All right, and then here we have an x to the fourth, right? What do you say? You gotta do w, but both sides aren't exactly the same yet. Yeah, multiply this up by 3. Now the bottoms are exactly the same. Okay, so then across the top, what do we get? Well, not really across. Let's just fix the top. So what I mean by that is basically multiply these together, keep the sign, multiply those together, all over one denominator. 15 minus 8. Wait, we have our 8. Yeah, our 8, and then w squared. Uh-huh. What about the x's? X to the 7th. Good, you added your powers. X to the 7th over 24w x to the 4th. All right. So then, um, is there any wiping out we can do right here? No. Why not? Yeah, because of the minus. Now, you breaking you have no conductivity. Now, if you had this was not here, and you had parentheses, and we brought that a bit closer, then could you wipe or do something, some sort of simplification? Well, you want to treat this as like a contained package. Like all of this is just like one thing in a container. Um, actually, yeah, it's just fine. Think of it like that, and then you can actually like reduce the 15 and the 24. You can actually combine the 15 and the 8 if you actually had this situation. Like these could actually multiply together. And there's no distributing because you don't have any pluses. It's not like if you had a plus right here, you would go like that and like that. But because you don't have a plus, you're just when you're multiplying these together, you just do that. But enough of the made-up problem. Okay, so that's it. There's no reducing. Can't do anything else. Okay. All right. So because the denominators are the same, I just think it's really rewarding to be able to go like this and go like that. All right, and then you get to just write everything like if the denominators are exactly the same, then you just write one at the bottom and then just write the top in a row. So it'll be 6r to the fourth s squared minus rs, like that. Okay. The only thing you really can do from here, like, can you divide things out? No, because there's no like 3 here. And unfortunately, or fortunately, the r to the fourth and the r can't talk. They cannot talk to each other through addition or subtraction. So this and this, like with an invisible 1 on it, because there's an invisible 1 right there, they can't talk. If you were multiplying them, you could. But if you're adding them, no. Can't communicate. You can't connect them. So this is your answer right here.